Okay guys, so let's go back and look at number 3, and let's look at the graphs of number 3. If you have your graphing calculators that you're supposed to come into class and grab from the back table, make sure that that's going to allow you to be able to put in parent functions and those new functions that you get on your worksheets and assignments. So as you can see, I went in, look at the blue graph. The blue graph is our parent function for absolute value. How I know that is because it says right here in blue, f1 of x equals, that's y equals the absolute value of x. So this blue graph right here is our parent function. All right, exactly how we drew it earlier on the actual assignment to see how the graph is going to move. Now our new function for question number 3 was, the actual assignment on the problem was f of x equals x plus 2. That's going to be this red graph. Does this red graph match up with what we came up with earlier? Yes, it does. It's shifted to the left, like I said earlier, 2 units. How I know that is because my vertex for my parent function started at the origin, then my new function shifted that vertex over 2 units to the left. If it's x plus 2 in parentheses or inside the absolute value bars, it's going to move it to the left 2. Why? Because it's inside. So we're looking at it actually as a factor. Okay? Now let's talk about domain and range. When we're looking at our new graph, which is the red graph. What is the domain for our new graph? So I'm going to go and grab this, and I'm going to actually work out the domain and range on this paper. So we're looking at our domain, D. Our domain, which is our x values. So that's what that means. It's just letting me know that you know what domain represents, our x values. So our x values, we're going to do it just like we did the last problem, the quadratic problem. What are my x values on this red graph? I know in actuality that this graph, I can expand out, and it's going to keep going and going. So that's why I always put arrows at the end, because this graph is going to keep getting larger and larger, higher and higher, and it's also going to get wider and wider, just like the quadratic equation did. All right? So it's saying, tell me what is the domain, which means tell me all of the x values. Well, if I'm looking, this graph over here on the left is going to keep going, it's going to keep expanding, and it's going to keep getting higher, which means it's going to get wider. Same thing on the left side. It's going to keep growing, getting higher. It's also going to expand and keep moving further to the left. So it's going to actually touch and cross over every single x value. It's not going to come down here and touch on this x-axis, but it's going to cross over where x value is at. Just like this point is here, this point is here, this point is here, this point is there. It's going to keep getting wider, which is, as it's expanding, it's going to keep touching over, crossing over each of these x values to the right and to the left. So our domain, again, is going to be all real numbers. You can either write out all real numbers, or you can draw that symbol right there. Now let's go to our range. Our range is our y values. So now we should be looking at our y-axis when we're trying to identify all of the y values that this graph is going to cross. Now I do see a stopping point for this red graph. My red graph stops. It has a vertex that's right here. So what is the y value for this point? Our y value is 0. So I'm going to write y, and I'm going to write 0 since it has a stopping or a starting point. But then where are the rest of my y values in context to 0? The rest of my y values are above 0. So if I'm looking at this red graph, I'm seeing 1, I'm seeing 2, I'm seeing 3, I'm seeing 4, I'm seeing 5, I'm seeing 6. It's going to keep getting higher and higher. That's what those arrows are for. So I can't write all real numbers, or you could write all real numbers greater than 0, or I'm just going to put the y values has to be greater than or equal to 0. Higher means greater. So higher than, which means greater than or equal to 0 for my y values. This is your domain and range for question number 3. All right, let's go to the last problem, question number 5. We've already done question number 4. We did count backwards, but question number 5. All right, question number 5. This is going to recall if we were actually paying attention last class, because I gave you the answer to this question. It says, which function below is a constant function? At the top of the section 2-7 paper, it gives you 4 functions in a table. All right? It gave you a constant function, number 1. It gave you a linear function, which is a diagonal function. It gave you, after a linear function, it gave you a absolute value function, and then it talked about the parabola, which is the U-shaped graph, the quadratic function. So which one of these functions do we think is going to give us a constant function? I'll remind you guys, a constant function is a straight line that's all the way on that function is going to be constant. Think about driving in a car. If I'm on the freeway and I'm driving where I set my cruise control, that means I'm driving at a constant rate. My rate is not going to change. I'm going to drive that same speed all the way from DeSoto to Arlington. I'm driving 20 miles per hour. So that constant function is going to be the same, so it's going to be a horizontal line. Which one of these functions would represent a horizontal line? Well, x squared, we already talked about. X squared is going to give us a U-shaped graph. X to the third, we haven't learned about cubic functions, but we will. That's going to give me like a squiggly S-shaped graph. If I type in b, y equals -4, that's y equals some number. I think that may be a constant function. So my answer may be b. But then if I go over here, this is a step function or a stair function. So that's going to give me where my graph is like lined up, and it keeps giving me like a staircase like we talked about last week. So my correct answer is going to be B. B is the only function that gives me f of x or y equals a number. How do I know it's a constant function? Because my slope is always 0 on a horizontal line. Y equals a number. I'll give you a hint. If we have y equals or f of x equals 0 times x plus 5. Well, 0 times anything you learned a long time ago, back in middle school. 0 times anything goes away, so it's going to give me f of x or y equals just that number. So that's how we know our slope is 0, which is going to produce a horizontal line, which is called a constant function. All right? So that goes over all of those. And let me know if you have questions. Make sure you're taking notes on this. Make sure you're actually turning this paper into your subs, because this is going to count for your grade for today. All right? So let me know if you have any questions. We do have tutoring today after school to anybody that wants to come to tutoring. Today after school, 3:30 to 4:30. Only an hour on Thursdays of my time I'm going to devote to staying after school to make sure that we're okay with the things that we've covered over in Algebra 2 that you don't quite understand, or you still have some more questions that you want to ask one-on-one. Thank you guys. See you later.